In this video, I will be showing you how point source atmospheric pollution is found in New Zealand. The area being studied is rural Taranaki. The Kapuni Gas Treatment plant is located in this area. This site was chosen because it's in a flat terrain and is relatively isolated from other sources of CO2. This considerably simplifies measurement and analysis. The plant started in 1971, which is very noticeable when looking at the change of the tree rings from that time to now. Scientists have been using tree ring analysis to measure the amount of emissions put into the atmosphere by this treatment plant. Electrician generation and industry are large point sources responsible for 1/3 of carbon emissions in the world. Carbon is the largest contributor to climate change, making it one of the most important ways to stop climate change. There are 2 trees being studied in this area, 1 pine tree and 1 chestnut tree. The pine tree is located 5 meters from the Kapuni stream and surrounded by other trees, while the chestnut is located in a flat field. Trees assimilate carbon from the atmosphere through photosynthesis, in the process recording the average atmospheric content in each new annual tree ring. The trees are studied between September 1st and April 30th because that's when photosynthesis is most active. At the Kapuni Gas Treatment plant, they process natural gas extracted from natural gas wells in the Taranaki Basin. The gas contains about 40% CO2, which is removed during processing and vented into the atmosphere. There is also an ammonia-urea manufacturing plant 500 meters west of the gas plant. The emissions of CO2 from these plants leads to radiative forces causing climate change. Because this is a rural area, much of the surrounding land is empty, but the carbon still affects the people around the plant. New Zealand is an island off the southeast coast of Australia. It's a large contributor of greenhouse gases that lead to climate change, meaning they are responsible for a lot of the ice melt occurring in the North and South poles. Islands are at risk to be completely gone to sea level rise if emissions continue at this rate, meaning if New Zealand doesn't fix these rates of emission, they will be hurting themselves in the end. When looking at New Zealand's history of emission from this time period, we see the emissions increased 23.2%. This accounts for the years of 1990 to 2014. The key drivers of the increase in gross emissions were carbon dioxide emissions from road transport and chemical industry, methane emissions from livestock digestion, nitrous oxide emissions associated with agricultural soil, and fluorinated gases released from industrial and household refrigeration and air conditioning. Net emissions increased 53.6%, largely due to the increase in gross emissions. New Zealand has 4 national targets for reducing these greenhouse gases, covering both the medium and the long term. These goals include a 2020 target of 30% below the 2005 greenhouse emissions, 5% below the 1990 emissions by 2020, a long-term target of 50% below the 1990 emissions by 2050, and a conditional target range of 10 to 20% below their 1990 emissions by 2020, if there is a comprehensible global agreement. They claim they will meet these targets through domestic emission reductions, the removal of carbon by forests, and participation in international carbon markets.